In this video, I'm going to show you how to make model engine valves out of an Allen screw. And the reason I use an Allen screw is two reasons. They're easier to lap, and it's easier to control the silver braze when you put the drill rod in there and silver braze it in. So what I'm making is, I'm using a 1/4 inch Allen screw for this valve, and this is the valve here that we'll be making. And as you can see, it still has the hex in the top. And the reason I want that hex there is two reasons. One, I can drop a small amount of silver braze in there and control the exact amount that's being used. And the second reason is it fits my special tool so I can lap it really easy. Now, I use two sizes of screws depending on the engine. Sometimes I use a number 10 screw, which is much smaller. But most of the time, I use a 1/4 inch, and all I'm using is just about this much of it, and you'll see in the machining that there's hardly anything left of the screw itself. There's just the head of the valve, and it's turned into a valve head. Through the years of making valves, I made them many different ways, and one of the ways I made them was with a single cut. In other words, this tool will take and make the valve stem the right size if you can set it right. And I used to make them out of 12L14, which worked really good. And I believe that you could make the intake valves out of brass and they would still work, because there's no heat involved hardly compared to a regular engine. But I'm talking about make and break engines, and the ones that most of us have, not those little V8s and so forth that scream and make a lot of heat. So those valves, you probably have to use stainless steel. These, you can use almost any metal. I use 12L14, and now I use, like I said, the head of this screw and a piece of drill rod. Okay, well, let's get to it. I'll show you the entire process for making this valve. I'm using a spotting drill to get the centered, and I'm putting the spotting drill in as far as I can and still hit the bottom so it won't flex at all. A 7/64 drill. It's not 1/8 yet. It's a small drill, and I'm going to just go in there a little ways. Okay, so what I've done is put a starter hole through there. I'm not going to drill it out to 1/8 yet. Actually, I would ream it to 1/8. I'm going to set this at 45 degrees. You got to square this. Okay. That's set. Okay, so I'm going to take a rounded point bit and go in there and shape the back end of that valve a little bit. Zoom right in on that. Yep. Okay, so I've left plenty of meat here, and I'm going to do that with another cut. So I'm going to use a small bit so I can get in behind there and just take a little light cut of 45 degrees there. Just make sure I got the whole face. I don't know if you can see it on the video, but I've done the whole face at 45 degrees exactly. Then when I do the valve seat, I'll do it at 44 degrees, so you'll have 1 degree of interference between the valve and the seat. Actually, I gotta drill it and ream it. So now, before I take it out of there, it's still in the same position. I'm gonna open that hole up to, this is a number 32 drill, and then I'm gonna ream it 1/8. I'm only going in there like 200,000, so a little more. So now we're going to ream it. Now I've got a piece of 1/8 drill rod. I want to make sure that that'll fit in that hole, and it does. It just goes in there nice and clean. Okay, now I can part it off. And I want to leave just enough to get a good silver braze joint, and it's a couple of 100,000 maximum. Okay, there it is, the valve head. Now I'm going to change the collet and put a 1/8 collet in. Now what I'm going to do is I'm going to check the run out of this collet before I silver braze the head on the valve, because it's easier to do it without the head on it. This is usually within 1/1000th, but I want a little better accuracy than that if I can get it. Okay, the high side is right here. So what I want to do is loosen that up. I'm going to have to mark the high side. Let's mark the low side, it's easier. I'm going to loosen this up, and I'm going to put a little shim in there. Take a 1/1000th shim right in here. That's better, but it's not quite enough. Now I'm within one. That's still the low side right there. So I'm going to go for 2/1000ths. So as you can see, that's running within 1/4 of 1/1000th. That's about as close as I can get this. I'm going to leave that shim in there, take my drill rod out, solder the head onto it, and then we're going to put it back in there and finish the valve. So I'm going to put the flux on the shaft and on the head. And then I'm going to wipe off the excess flux that's underneath it with a rag. I don't want that silver braze to migrate down the shaft too far, so then I'll have to remove it. If I just do this, it should be perfect. Okay, here's the second advantage to using the valve head. I'm going to drop a little piece of silver braze inside that socket head, and it only has to be a tiny, tiny piece. As you can see, that's very tiny. I'm just going to heat that from the bottom until the silver braze runs down in. There it goes. You can see the silver braze ran right down in there. Now, if I had put that on the shaft, I would have a lot of silver braze all over the valve stem, and I'd have to clean that off if it went down far enough. So this saves that, and it also controls the amount of silver braze you use very nicely by putting it in that little pocket. There you can see it came down a little bit on this side, but that's fine. That won't interfere with anything. Okay, so I put it back in there. I know it's running pretty true, but what I'm going to do is I'm going to have to take a little bit off the head again to true it up, because when that solder's on there, it isn't perfect. See how it wobbles? But that's okay, I can true this up. See, now I'm going to take off the head of the valve just to make it flat. No real reason that I have to do that, but I don't like the thing wiggling like this. That trued it up. Now I'm just going to clean up the bottom just a little bit. It's not really necessary, but makes it look prettier. And what you want is the air coming in or going out, you want it to go in a flow, so you don't want to leave any ridge there to interfere with the flow of the air. So there's the finished valve, and now I'll cut it to length and put the hole in the end of it for the keeper. So I'm going to saw this off right here. So the next thing is you've got to put a hole in here for the keeper. There's the keeper, and what I use is a piece of 32 thousandths wire, and I want a hole right near the end. And to do that, I have this jig, and it's already set for valves. I put the stem of the valve in there and drill down through this hole, and I've got the perfect hole, which is 40 thousandths. A little cutting oil, hold the stem in. Very light pressure. You don't want to break the drill off in there. There it is. There's the hole right in the end. So the next thing to do is to lap that valve in. And what I have here is a valve chamber for this engine here. And it's already got the valve seat cut in it, which is only approximately 15 or 20 thousandths wide. You probably can't see it. It's almost a perfect corner, but it's just taking the corner off all the way around as little as I can. And the valve should fit in there, and now I'm going to lap it in that position. What I've got here is 280 grit lapping compound. It's silicon carbide. That's what I use. I also have 500, but that doesn't cut very well. So 280 has worked pretty well. A little bit on the seat. Drop the valve in there. This is a special tool that I made up that fits in that hex. The hex in the top and the advantages of having that. And this special tool is made out of an Allen wrench. It's a Bundus with the end so it can swivel. And I can put that in there and I can lap it real easy. Screw head helps. See how easy that is to lap? And I can push it up from the bottom, restart it. That's sounding pretty good. I'll take it out and wipe it off real good. I don't know if we can see on the video, but you can see that it's contacting all the way around, right about in the middle, a little bit shy of the middle. So I actually could have taken more of this valve head off, but it's not necessary. But you can see that it's hitting all the way around. No, you want to make sure you get all that lapping compound out of there. You don't want get any down in the stem, because it's going to wear the stem fast. And the valve guide, so get that good and clean. And the next thing you want to check is alignment. There shouldn't be any resistance. When you push that valve down in, it should pop right up. There it is. It fits very tight. This is the intake valve. The exhaust valve, it doesn't matter really how tight it is. It's just going to leak a little out of here, and it doesn't matter with the exhaust. But with the intake, when you're taking in the air, you don't want a lot of air sucking in here and screwing up the mixture. So you want a fairly close fitting valve for the intake. Now, if you push the valve down in there and it sticks, it's off center. Something is wrong. Either the valve guide is not straight or the valve isn't straight. You should be able to put that down in there, push it down hard, and then just push it right back up. Now we'll test it. I'm going to put it here. Okay. The way I test valves is with this kit. This is a brake kit for an automobile, and it's to pull a vacuum on the brake lines to suck the air out. And these cost like 14 bucks or 15 bucks on Amazon. Of course, that's when I bought it. It's probably 30 bucks by now. But what I did is I made a special adapter, and all my carburetors go on the same way. Let me see if I got a carburetor here and show you. I put my carburetors on with an O-ring, and you can see it just fits on there like that. That way I can take them off and work on them and put them back on, or I can swap this from one engine to another and check if I know it works on this engine, it should work on another engine. And most of these are pretty much the same for the engines that I build, so it's swapping around is no problem. So what I did is I made a fitting to go onto that, the carburetor one, and I can test the intake valve. And let's show you a valve. This is an unlapped valve. So this is a valve that wasn't lapped, and as you can see, it holds a little air pressure, but not very well. That would probably almost work. It goes down pretty slow, but if I pop it, it goes. But then, here's the valve that I just lapped in. As you can see, that holds a lot better. And you're never going to get one that holds completely because it leaks around the valve stem a little bit. But if you get it to hold that good, you're in. And especially the intake valve, because the intake valve has a very light spring on it. The exhaust valve has a stronger spring. Now that's holding, that's really good. Wow. That's the best I ever did. That's what you should expect. It's going to leak a little bit, but it's probably just around the stem that it's leaking. And the way you can test that is put oil on the stem. Boy, that's incredible. And if you put a little oil around the seat, it should stop that even. Let's see. Wow. Now that's a good seating valve. We'll put the spring on it. And then I need to cut a piece of wire. This is the wire I use to go in there. I'll put it in so it sticks through, and take a pair of nippers and nip it off, and that will be complete. Just going to test it with the spring on it. And as that runs, it will pound itself in, and eventually you'll get a perfect seal. But as long as it holds long enough to crank it over, you can see that's pretty doggone good. That's about as good as you could ever expect. The engine will start, and once it runs a while, it'll pound itself down in there, and it'll be a really good seal. What I'm going to do is I'm going to put a little oil on this stem right up front to try to cut down the leakage there. And then we're going to test this exhaust valve in place. And this could be anything because it's a new engine and I haven't run it yet, so let's just see what happens. See, that was set pretty good. So that's without holding any pressure on the valve. If I hold some pressure, it's a little better, you can see. So there's a tiny bit of leakage, but that's going to be plenty to start the engine. And once it runs a few minutes, the valve will seat much better. As long as you get enough compression to start it, actually that's pretty good. And I've got some leakage here, I'm sure. So that's about it. If you liked what you saw, please subscribe to my channel and give me a thumbs up. We appreciate it. I'll see you in the next video. Thank you.